Hello everyone, with the release of version 1.85 of Nomad Sculpt, a tool for automatic and semi-automatic retopology has been introduced. It's called Quad Remesher, and today we'll try to explore how to work with it. Also today I'll try to show you a general, classic algorithm of sculpting for smoothing. We will also consider such a combination as working with the model through voxel remeshing. And then we'll clone the model and transfer the detailing to the cloned model. In general, for now, it all sounds very complex, but don't worry, we'll figure it all out together. So, my friends, Quad Remesher is an excellent tool for creating topology for smoothing. It helps us achieve smoother and cleaner lines and shapes, and it's located here. Yes, to start with, you'll need to purchase it if you haven't already. But I don't think you'll have any difficulties with that. I'll take such a pre-made cylinder with a face group drawn on it. It has such a dense grid made using voxel remeshing. Let me recalculate this grid again. So as you can see, I now have symmetry enabled. In the Quad Remesher settings, I'll set the value to 2000. When I press the remesh button, the grid will be recalculated into a completely different, more neatly organized grid. If symmetry is enabled, then the result will be symmetric. When using Quad Remesher, the model becomes much lower in polygons compared to the original. The system tries to preserve this relief somehow. You see how rings of polygons appear, neatly and cleanly, and then what can we do? Well, for example, press subdivide and get a more detailed result of the same model. So, once again, we saw how the remesh button works. If I now go back and disable symmetry, and with symmetry disabled, press remesh, I'll get the following result. The grid will not be perfectly symmetrical. You might wonder why these peculiarities exist. It's all because when symmetry is enabled, the program does the following. It takes and creates a symmetrical model with the automatically activated mirror function. In other words, it takes, creates a new grid and reflects the left side onto the right. When symmetry is disabled, we get a grid without an axis here. If I now press mirroring, you'll see how it turns out? So externally, it looks like a symmetrical grid, but in reality, the mirror function shows that it is not symmetrical. What's all this for? It's for the following. For example, when our model is absolutely symmetrical, we enable remesh with symmetry enabled. If our model, let's say, is not symmetrical, let's make one eye bigger for him. Look, with symmetry enabled, we'll get this situation, press remesh, and you'll see what happens. It reflects one side into the other. But if we disable symmetry, it will make the model as it is, but without preserving the central axis. Let's move on. Click on these three dots to open the Quad Remesher settings menu and disable all these settings. You might wonder how the target quad slider works. It's simple. It controls the number of polygons during the recalculation. This is an approximate value, and it will vary slightly depending on whether we enable the other functions in this menu or not. Initially, the adaptive quad count function is enabled here, and it works very simply. Its purpose is to add additional edges or densify the grid in areas with sharp changes in surface direction. Roughly speaking, for example, areas at 90-degree angles or some additional detailing on the model. So, if adaptive quad count is enabled, an adaptive size is turned to the maximum. The polygon density in these areas increases. If it's disabled and then you press the remesh button again, you'll see that the polygon density will be balanced. There won't be any unnatural bends. You see that the polygonalization becomes as evenly distributed as possible. Below is the auto detect hard edge function, which essentially speaks for itself. It automatically detects sharp edges on your model during mesh recalculation. The next thing we'll look at is a tool called Face Group. What does it do? I think you've already guessed. If, for example, on our model, we have such colored groups of polygons, when the Face Group function is enabled, these polygon groups will be preserved after pressing Remesh. The Relax parameter changes the edges and the grid of this polygon group. If we want to preserve the angularity of this polygon group as accurately as possible, we can set the Relax value to 0. I'll open a prepared model. Let's leave the target count parameter as it is, 2000, and the adaptive size can be 70%. Press Remesh, and we get a very good grid for smoothing. If we want a more organized grid that builds as we want it, we need to make guides so that the grid is built neatly. For this, we have the curve guide. I'll go back a step and show you how it works. This brush is needed so that you can suggest directions in which you would like the grid to go. Just suggest. Trying to draw an absolutely accurate grid of polygons here is utterly pointless. So it's more of a tool needed for setting basic directions of the grid. No more than that, keep in mind. Let's see what came out. In principle, it's not too bad either. To remove these curves, click here on the cross next to the guide label. I'll bring them back because I still need them. There's another technique, or rather a function that I missed, density painting. How does it work? Let's turn everything off and leave only density enabled. Select the brush called dot density. We'll set the intensity value here to the maximum. So here's how it works. This slider controls the local density of the grid. So if I set the value here, for example, to 100 and mark the facial area in red, the polygon density in that area will be higher. Next, I'll set the density to the minimum, for example, and paint somewhere here. So I'm assigning polygon density. For example, the back of the head, which will be hidden under clothing, I'll make less dense. Well, let's see what we get. So we've set the guide's curve and we've also painted density. Now, when we use Remesh, we'll get a new topology. Where it's red, the grid will be denser, and where it's blue, the polygons will be larger. I'm not sure if I'm satisfied with the result, but I think you understand the principle. What's the purpose of this principle? For example, you've made your sketch and you know for sure that this part of your character will be hidden under hair or a hat. Then, when you press subdivide, there's no need to increase the polygon density here. But but it would be very good to work on lashes and eyes. However, it's essential to closely monitor the transition from one grid to another. This is also achieved purely experimentally and through experience. Now I can comfortably detail the model as needed. We press subdivide further and work on the medium details and so on. That's how we figured out how the Quad Remesher tool works. And I'll also remind you about the convenience of using keyboard shortcuts. Let's go over the algorithm again. It's a classic algorithm for creating a neat model. So initially, when I work, I always use voxel remeshing. Let's imagine that I have assembled this head with classic blocking from primitives. A sphere for the head, a cylinder for the neck, and so on, and made a rough sketch of the shape. Only the overall shape, no details. A very rough blank. So initially, it's always voxel remeshing. It's very fast, very simple, and doesn't require complex technical actions. The main thing here is to start from simple forms. Don't try to overly detail. In general, we do traditional blocking. I don't make any wrinkles, I don't do anything like that. I never work on small details right away. So when these shapes are outlined, the next step for me is to transfer the model to another grid using Quad Remesher. It's a straightforward procedure, as you understand. That is, if we have already decided on the sketch, then you just need to press the remesh button with symmetry enabled since my model is symmetrical. I can set guide, or I can even do it without these guides. Just press the remesh button. Overall, Quad Remesher is a tool for creating topology for smoothing. Yes, you can use it as a basis for further mesh editing in other production programs, but mainly, of course, it's all done for smoothing, nothing more. Once Quad Remesher has done everything, I can calmly continue working on this model. So the algorithm is as follows. First, you create a shape from primitives. In other words, you do blocking. Then you stitch all these elements using voxel remeshing. Then you press Quad Remesher. This gives us a new grid. Then I press subdivide and start gradually working on the model. I work on the main key areas. At the same time, I can very easily and simply adjust the shape of the lips if I need to smooth somewhere, and so on. Then, with each press of subdivide, I start working on the details. It is very important to gradually increase the level of detail. I didn't increase the mesh density drastically, meaning I didn't press subdivide 10 times and then try to work on small details. No, everything goes gradually. As you can see, I reach the detail on the lips at a certain stage. The main thing in this matter is gradualness. If suddenly I want to add something here, than most, often I go back to the lowest level again and do the following. If here I mean to add a fold, I've done it here. I go up a little to the next level, work on the fold a bit more, refine it, go up again, refine it again. That is, I move through these levels like this. What else is the plus of such work? Actually, if I work with detail levels, then if suddenly I need to change the proportions of the face, I go down to the very first level, take a big brush, and for example, adjust the proportions, like this. Then I go back up the levels to work on the small details. I hope it's clear to you. But mostly, for example, I work with a slightly different method, and I'll show it to you now. Let me open another model, for example. So here it is. Sometimes your sketch is so detailed that there are some very small details. But as you understand, if I just press the remesh button now, all this detailing will, of course, disappear. And essentially, I'll have to press subdivide and redraw everything again. But I think this is not our option. This is not what I would like to use. So something needs to be understood. Firstly, your project may consist of different separate parts. For example, horns, claws, and everything else you created there. So basically, when you have a project consisting of a different number of separate details, then we need to create retopology separately for each detail. Secondly, when you work with more detailed models, your process looks like this. You press clone, you get a duplicate of this model. If something else is visible on the screen, click on the eye to hide everything except these two identical objects. Then I work only with these objects. I'll rename one of them just in case, to avoid confusion, like retop. And the other one, sketch. Retop always goes on top. So for now, it's one object inside another. That is, they are in the same place. I'll hide sketch for now for convenience. Press remesh. Try it with these settings. Usually the values of Quad Remesher are set quite individually. The main thing is for the first level of detail to be low. The polygonal mesh is very, very simple so that you can easily edit, move, change proportions, and so on. And don't forget, if the model is initially symmetrical, then symmetry must be turned on. So we got such a grid, we activate the display of our second object, sketch. Here it is, it's more detailed. And in the end, we should do this thing. There is a reproject function. So the procedure looks like this. We enable our two objects that we work with. And being on the active retop, we press the subdivide button in this menu. Then from high res in this menu. The meaning of this button is to stretch the low polygon model onto the high polygon one. Then press subdivide again to increase the number of polygons, and again from high res. Repeat several times. This smooth process allows us to smoothly transfer all the detailing without any artifacts and do it as neatly as possible. In this case, as you can see, all the main details are transferred. This is just about when to stop. That is, the main thing is for all the main details to be transferred. And now again, you understand that initially when creating the grid. I could, for example, use density painting to mark areas, more detailed and less detailed, and thus build some guides. Well, I hope I have clearly explained the principles of creating semi-automatic and automatic retopology. I'm waiting for your feedback. Thank you for watching. Don't forget to subscribe to the channel for more content like this. Stay tuned for what's coming next. See you in the next video.